In this video, we're going to talk about experimental design, and we'll do ethics in a different video. So, talking about an experiment is investigating the relationship between two variables. Now, there's kind of two ways of doing this. There's an experiment, and then there's what's called an observational study. Now, the definition here, observational study, measures the value of a response variable without attempting to influence the value of either the response or explanatory variable. Well, they're using terminology that we haven't discussed. So here, I kind of left the page up so we could look down at the key terms. And down here, key terms, they kind of tell us what those mean. So when one variable causes change in another, we call the first variable the explanatory variable. The affected variable is called the response variable. So we have this idea that there's a variable that occurs that causes some sort of response. So the explanatory variable is causing a response variable. All right, so an observational study, let's come back up to that, measures the response variable without influencing any of the variables. So it's this absence of influence. And that's the difference between an observational study and an experiment. An experiment is attempting to influence and see what happens with the response variable. So they might play around with the explanatory variable and kind of see what happens. So let's look at this example. Suppose you want to see if listening to instrumental music while studying improves improves, helps. That's funny. Should just say improves learning or helps learning, not both. Maybe here we'll put the word or. There you go. That fixed it. So, how would this look as an observational study? So, as an observational study, we'd probably just give a survey to students. Now, this would be done with a good sample. Okay, so assuming that we know our sampling techniques. So, we give a survey to students, and maybe in the survey, we ask, do you listen to instrumental music when you study? Now, the question is, does that improve their learning? So, what we'd have to find then is some way of measuring learning between students. So, maybe we would then find out their GPA. Or if we're looking at a specific group of students who came out of a class, we could ask their grades in the class, their final grade in the class, with some anonymity to ensure that they don't feel like they're going to be giving that information away to just anybody. So we'll ask those information, kind of do a comparison. The problem, of course, is that just because somebody does listen to instrumental music when studying doesn't necessarily always going to associate them with a high GPA. There might be other factors there, other variables playing into it. So the observational study is really only going to allow us to show a correlation between maybe people who listen to instrumental music and doing well in school. All right. But as an experiment, that's when you would go to students and you have the students listen to instrumental music. So you ask them to listen to the music when studying. And then we maybe create some way of measuring whether it has improved their learning. So maybe for one term, we ask them to just do their normal studying, don't listen to instrumental music, see how they do. And then maybe we look at them another term and ask them to listen to the instrumental music and see if maybe their grades have improved. Now, the problem with that is it's a little bit loosey-goosey with how many variables are possible in that scenario. So maybe we'll do something a little bit more strict, like we make them sit in a controlled course. Have them, take a test, see how they do. Then maybe kind of see, like, have two types of students. So maybe one group of students listens to the music and another group doesn't, and we just see how they do in the course, this controlled course that maybe we force them to go into. So that would be a way of kind of creating this as an experiment, and by issuing control and having them kind of do these kind of categories of you listen to music, instrumental music, and you guys don't, allows us to see if there's an actual causation. And that's the power of an experiment, is we can prove causation. But of course, setting this up is a hell of a lot more expensive than our first part, doing an observational study, just asking people. And that's why we see more observational studies than we do see experiments, because experiments can be pretty expensive. Okay, so there's a couple other phrases we should know. Treatment. So the different values of explanatory variables are called treatments. So the way we affect the explanatory variables, those are our treatments. So like in this case, having people listen to the instrumental music, that's the treatment. Maybe we have them don't listen to the instrumental music. That's the treatment. An experimental unit is a single object or individual to be measured. So these are the actual people that we're studying, or, depending on what type of experiment it is, it could be something else. And note, in a randomized experiment, the researcher manipulates the value of the explanatory variable and measures the resulting changes in the response. So they are manipulating. They are issuing control, whereas an observational study, there is no control over that. They don't influence it. They just ask the questions. Okay, so let's kind of look at this terminology in an example. I'm going to zoom in just a smidge here so that my writing is a little cleaner. Researchers want to investigate whether taking aspirin regularly reduces the risk of a heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin and the other group will take a placebo. Each man will take one pill each day for 3 years. That's a long time. But he does not know whether he's taking aspirin or the placebo. At the end of the study, the researchers count the number of men in each group who have had heart attacks. So let's identify in this example all of these terminology. So the population that we're looking at are men, men ages 50 to 84. My writing is still a little sloppy, but hopefully that's readable. Okay. In this, the sample is they took 400 men to participate. The experimental units are these actual individual men among the 400. Okay. The explanatory variable in this. So the explanatory variable is we're checking to see, right, if taking aspirin reduces heart attacks. So we're looking to see if aspirin is reducing heart attacks. So that's the thing that we're trying to explain. But we actually have two levels. Some are taking aspirin and some are taking a placebo. So in this case, the explanatory variable is that they're taking a medication, an oral medication. So each of them are actually taking a medication, maybe the placebo or the aspirin. The response that we're interested in, that we're concerned about, of course, is whether or not they're going to have a heart attack. And this is why they gave it 3 years. It's going to take time. Maybe somebody might have a heart attack a month after doing this. Somebody might have a heart attack 2 years after doing this study, right? The question is, are those the people taking placebo, or are they happening at a more frequent rate than those who are not? Okay, so the treatments are the two pills. That would be the aspirin and the placebo. Okay. Now we haven't really said what a placebo is, but they do define that real quick. A placebo is a treatment that cannot influence the response variable. So it's kind of like a control, a way of a base measurement. They often call the people who would take the placebo a control group. Okay. Oh, that's funny. That's our next little group, terminology. So, to counter the power of suggestion, researchers set aside one treatment group as the control group who do not receive treatment. So, this is if we're worried that maybe the people might be influenced by not taking anything at all. And therefore, maybe they treat themselves worse. They go on, living poorer lives than the people maybe who would take the aspirin. So by giving them a pill, we might be encouraging them to take care of themselves and therefore kind of put themselves at a level footing with the others. Blinding in an experiment means a person involved in the research study does not know if they received the treatment. So again, it's kind of trying to make sure that we're not biasing them. So we're there is such an issue as what's called the placebo effect, when somebody takes something and believes that they're going to be better just from doing the placebo. So the blinding kind of helps us see if something might be a placebo effect. If people just feeling like they might be doing something better is enough to improve their health or whatever it is we're looking at. Double blind is when both the subject and the researcher don't know what pill they're taking or what they're being assigned. A lurking variable is an explanatory variable that wasn't considered during a study. It is horrible. Lurking variables are the worst. It means that they did their experiment and all of a sudden they realized that they never took into account that maybe something else is going to affect them. So maybe they didn't ask these people who participated in the study whether their families have a history of heart attack. Ask questions about their fathers or grandfathers and seeing, if is there a history in their family where maybe people are dying from heart attacks and they may need to have done that. A random assignment is when they randomly assign people to the treatment, and that helps with lurking variables. So if you forgot to ask that question about their family history and you randomly assign people, it's very possible then that more than one person with an issue in their family history is going to be in both groups, and therefore it kind of balances out the results. Because they're both there in both groups, we may not have to worry that the results are somehow skewed or incorrect. Okay, so let's look at another example, kind of going through some of this terminology even further. The Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects completed mazes multiple times while wearing masks. Oh, that's a way of checking for learning. They completed the pencil and paper mazes 3 times wearing floral scented masks and 3 times with unscented masks. Participants were assigned at random to wear the floral mask during the first 3 trials or during the last 3 trials. So whether they wore it first or last, that's what was kind of random. For each trial, researchers recorded the time it took to complete the maze and the subject's impression of the mass scent, whether it was a positive, negative, or they were neutral. Okay, so what are the explanatory variables in this study and what are the response variables? So the explanatory is the scent. We're interested in whether or not the scent affected their learning. So the explanatory is the scent. And the response is well, in this particular case, we're looking to see how well they did at completing the maze, right? So it was the time to complete the maze. So they actually timed them. All right. So the treatments are they had a floral scented mask and an unscented mask. Okay, so lurking variables. Are there any lurking variables that are going to be problematic? Well, the answer is probably no. They did do some randomization, and randomization does help with potential lurking variables. So the randomization was that they randomized whether or not they were going to start with an unscented mask or a scented mask. And that randomization might help with maybe the fact that somebody just gets better at doing mazes the longer they sit there doing mazes, right? Or maybe as somebody gets tired as they're doing mazes and they do worse as they go. So the idea is by randomly assigning them to the floral being first or the unscented being first, they kind of balance out those groups of people. So no, the answer would be since everybody did both treatments, so both treatments were applied. And there was randomization. then we could probably safely say that there really are no lurking variables that we need to be worried about. All right, is it possible to use blinding in this study? No, that doesn't make sense because the minute they smell the floral scented mask, they know they have the floral scented mask. So, no, the floral scent gives away, which is why they had everybody try both. That because there wasn't a way of doing some sort of blinding, that means that it was important that they did both so that they could see how they would behave. Okay, so one more example to do. A researcher wants to study the effects of birth order on personality. Explain why this study could not be conducted as a randomized experiment. What is the problem in a study that cannot be designed as a randomized experiment? So, in this particular study, the explanatory variable is the birth order. And since that's the explanatory variable, there's no way to randomly assign it. You can't force somebody to have a birthday on a specific day. So it cannot be randomly assigned. So no, you couldn't do a random assignment, which means we have the potential of lurking variables. And that's the problem. So not having a random assignment means that we're going to possibly have issues with lurking variables. And it's possible then that there might be differences based on that reason and that reason alone.